This video is for chapter 3, section 4 from our text. This would be the triangle sum theorem. It is intended to be looked at after we have studied parallel lines. If you have not done any studying with the parallel lines in chapter 3, section 1 or section 2 and those assignments, it is not appropriate to be looking at this lesson based on how we are going to define the triangle sum theorem. Before we go into the actual theorem and some of the things that we'll look at, we are going to move over to the sideboard and actually prove what this triangle sum theorem is all about. Okay, so before we begin our lesson on the triangle sum theorem, we're going to look at the proof of it and find out what it's all about. The proof is already here. We're not developing it on our own. We're just going to look and see if we understand it. Given that these lines are parallel, so they're already parallel, we want to prove that angle 1, 2, and 3, the three angles inside the triangle, add up to 180. Here's what I have started with. Angle 1 and 5 are alternate interior angles. Yep, by definition they are. That means they're congruent by the alternate interior angle theorem because the lines are parallel. Well, the definition of congruent angles is angles that are equal to each other in measure. So I have 1 is equal to 5. Well, 3 and 4 are also alternate interior. That makes them congruent, which makes them equal for the exact same reasons. I have 3 equal to 4. Now I can say that angle 5 plus angle 2 plus angle 4 adds up to 180. This is the angle addition postulate. Part plus part plus part equals whole. With a simple substitution, 1 for 5, 3 for 4, I can now claim that angle 1, 2, and 3 add up to 180 degrees. This was a very quick look at the proof of why the three angles inside of a triangle always add up to 180 degrees. Feel free to pause the video, write down the proof, or at least look at the statements and reasons to make sure they make sense. From here, we can now say we know the triangle sum theorem. The three angles of a triangle add up to 180 degrees. Okay, so now that we have looked at the proof of the triangle sum theorem and we believe that the angles inside of a triangle add up to 180, we can go into the other details of this lesson. So, the triangle sum theorem, as we just learned, says that the sum of the measures of the angles of a triangle add up to 180 degrees. If this is my triangle, we can claim the measure of angle A plus measure of angle B plus the measure of angle C equals 180. Why? The triangle sum theorem tells us so. On a very basic level, what would an example look like? Maybe something like this. Here's a right triangle, and we don't know what x is. But we do, because we know the total is 180 degrees. So we could take 58 plus 90 plus x and add them up to 180. We probably see that as just taking 180 and subtracting 90. So that means there's 90 left. And we subtract 58 from that, and we see what's left. X ends up equaling 32. As we move from the triangle sum theorem, which talks about the interior angles of a triangle, we're going to take a look at an exterior angle of a triangle. So any angle that is formed by a side and an extension of a different side is called an exterior angle. Here's my example of an exterior angle, angle 1. This is an extension of the side, and this is a side. So exterior angles occur at any point on a triangle. If I was able to draw one to make sure we understood, I might want to check that we know that angle 1 is an exterior angle. Angle 2 is also an exterior angle. Angle 3 is not an exterior angle. It is vertical to the interior angle. Exterior angles must be adjacent. Good thing to write down. An exterior angle must be adjacent to an interior angle. That's one way to know that we have identified the correct angle. Now, for every single exterior angle of a triangle, there are two non-adjacent interior angles. There's one adjacent interior angle but there are two that are not adjacent. So we call those the remote interior angles. You cannot have remote interior angles without an exterior angle to be talking about. We would never call angle 2 and 3 remote interior unless we had already asked ourselves about 1. Angle 1 is exterior. Angle 2 and 3 are remote interior angles to angle 1. Only in relationship to angle 1. And that was our definition of exterior angles. Let's look at something we know about them. There is the exterior angle theorem. The exterior angle theorem tells us that the exterior angle, let's take a look at it again, angle 1, has a relationship to angles 2 and 3. I might have these numbers backwards. And that relationship comes from angle 4. We know the measure of angle 1 plus the measure of angle 4 is equal to 180. Well, we also have learned that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. That's the triangle sum theorem. Here we have linear supplementary angles. Here we have the triangle sum theorem. But what I notice is that 180 and the measure of angle 4 is in both of these equations. This leaves us to conclude, although we're not writing up a formal proof, which we could, that angle 1 must be exactly the same thing as angle 2 plus 3. This is the exterior angle theorem. It says the measure of the exterior angle of a triangle is always equal to the sum of the remote interior angles. This is one really easy way to find the measurement of an exterior angle. Add up the two interior angles that it's not touching. One little side note is that that means you can guarantee that the exterior angle is always bigger than either of the interior angles. It has to be bigger than 2 because it's 2 plus 3. It has to be bigger than 3 because it's 3 plus 2. So, the exterior angle theorem says the measurement of an exterior angle is equal to the sum of the two remote interior angles. To wrap things up for today, we're going to talk about how we classify triangles. Classifying triangles is just like classifying angles. We're going to look inside the triangle, look at the angles, and come up with a relationship. So, before we do angles though, we're also going to classify by sides. This is an added thing for triangles. If all three sides are congruent, we're going to call this equilateral. All sides congruent. Equa, equal. Lateral, like lateraling something sideways or lateral movement. Okay, that's side-to-side movement. Equal sides. Isosceles. Isosceles means there are at least two sides congruent. Now, if we're really paying attention, we understand, wait, at least two sides congruent? What does that mean? Why at least? How come it doesn't just say 2? Because this is an isosceles triangle as well. This is just a very special isosceles triangle that has the third side. So 2 sides, isosceles. 3 sides, still isosceles, but a better name is equilateral. Finally, we have the triangle that has no congruent sides. This is called scalene. Hopefully you're already familiar with these words. Now to the angles. We have 4 triangles here. One is not marked. I'm going to attempt to mark it in as we go. One is, what if all 3 of the angles started off congruent? What kind of triangle would we want to call this? Well, this was equilateral, lateral meaning sides. So this we'll call equiangular, equal angles. Turns out later we're going to learn and prove that these 2 triangles are exactly the same. Next we have this triangle here in which every single angle inside this triangle is acute. They are all less than 90. So all acute angles, acute triangle. This triangle should be relatively obvious now. It is a right triangle. Notice it does not say all right angles. That would be impossible. 90 plus 90 plus 90 would be 270 degrees. But the triangle has to add up to 180. One of them is 90. And here's a cool side note to write down. The other two must add up to 90. 90. These two add up to 90. Which means they're complementary. A theorem in geometry that we don't often put up is that the other angles in a right triangle are complementary, always. Finally, we have an obtuse triangle, which has one obtuse angle. It can't have two. Two angles greater than 90 would add up to greater than 180, and we wouldn't have a triangle. So one obtuse angle, two acute, obtuse. One right, two acute, right triangle. Three acute, acute triangle. It really all depends on what the largest angle within the triangle is. Because they always have two acute angles and then one large one, and that's where you make your decision. We will look at examples in class as how to use these theorems and how to do these justifications, and then we will begin to work on the assignment related to Chapter 3, Section 4.